Hello, can you hear me? We had an attempt where I wasn't heard, but I think it's working now. I don't know what happened. Yeah, okay, good. I keep looking here because that's where my monitor is. So we got a new setup. There's a new camera and then another camera here that is showing here the bench, and you'll see the sort of tabletop whatever pointing down camera in action soon. And so yeah, we're improving after many hundreds of pounds later. We might get the focus right. Alright, so some of you have already received PIPS, which is our current project. Sent it on Tuesday. And so I wanted to do two things. A first video of a build, so building it, soldering it, and seeing that it's working. And then another, take a break, and either today or Monday do a video on the circuit itself, and how it works, why it works, and some interesting things there. And we have a new scope, this thing here, and it's a 4-channel scope, so I'll be able to get some signals, and we'll look at what's actually happening when the thing is working. So but I don't think I can do it in both things in one go, so it's just a bit too much talking for me. So we'll do it in two rounds. Besides, I need to prepare things, different kind of video. Okay, so let's transition to which one is it? This thing? No. Yeah. Okay. So this is the tabletop view, and you got a side view here, the soldering station. Let me know if this works for you. I'm just trying things out at the moment. It's definitely going to show focus better. Yeah, somebody's complaining about the echo. I think it started raining. So there's from the roof. You're hearing some of the noise. Maybe that's that. Maybe it's an echo. Anyway, we'll continue on and deal with it some other time. Oh, I see what's happening. Sorry. Now, there's no echo now, right? There's no echo? No echo. Yeah, it should stop. For some reason, all of a sudden it decided to pick up the audio from 2 cameras. Okay, yeah. So I see that now. Something's wrong with the audio. It's acting up. But anyway, I disabled the one from the top camera. Maybe it's something to do with it's auto triggering. Anyway, whatever. It's done. It is raining though. So yeah, this focus thing is neat. It's working. All right. First, so this is a website of the of PIPS. So if you go to boldport.com/PIPS or /products/PIPS, and you have the components, wonderful pictures, and some information about how it works. But we're interested in this thing, which is the schematic and the assembly information. which I've got here printed. This thing can also zoom in, which is nice, right? Yeah, okay. All right, so I'll leave this outside here for my own reference. Okay, so it comes in this nice little bag. Oh, I know, I've forgotten my soldering mat, but we'll try not to damage this thing. You have the board, the bag of components, and you also get a nice die that matches the color scheme of the board. The board is called, the project is called PIPS, and PIPS is the name for the dots on a die or other things that have a similar thing. There's a thing here on the back. Check yours when you get it. Alright, let's put this thing aside. So the components. Now I'm going to solder, but before I do, in the workshop downstairs we have an air filter and all the proper equipment for soldering in a safe and healthy manner. But here it would be quite difficult to film with that, so I don't have that here. But you know, solder safe when you do. All right, board, got the reference, how to do it, how to where to get components, to put the components. Yeah, also ESD is important. So ground yourself before touching these chips. Right. So this is the final board. I'm showing this just so you know that there are some options. You can solder the LEDs on this side or on the other side, but then the diagonals are going to be different. So if you solder it on the component side, the diagonal is going to be what you'd expect. Actually, on a die, it can go either way. No, it can't. Sorry, no. So you'd on a regular die, you'd expect the 3 to be that way, you know, and a 2 to be that way. And so if you solder it on the other side, you'd have it sort of the wrong way. It'd be like that rather than like that. But you know, that's a minor thing. So that's an option. I'm going to solder it like this for this one. And then the battery contacts, you can also solder both ways. You can either solder it like that, and it'll sit like this, or you can solder it in the front, and the battery will sit like this. So up to you, but we're going to solder it just like this one in the back. Okay. So we have 7 LEDs. 5 diodes, a button, a PNP, BJT transistor, the contacts, 2 capacitors, and 2 sets of resistors. So we'll start with the diodes. Now, as I showed you in the other video, here it doesn't quite matter, but I just, if you pull on both ends, you get this nice, basically a holder until you need to plug each one out. Sometimes some will be on this side and some will be on the other. And in this board, I decided to just have little symbols for each component. So 4 squares is a resistor, 3 squares is a diode, and the sort of triangle points to the cathode, and a capacitor is 2. Two squares. So let's place them. So I just bend them with, bend them with my hand and place them. Now there are quite a few ways of doing this, but I tend to just bend these as tight as possible while maintaining the component in the center. It still wiggles a little bit, but that's okay. And then I'll do a few of those at a time. Now I'm going to do the domes, the domes in the end, so that's why the bending doesn't matter so much, because you're going to clip it anyway very close to the board. So where are the other 2 here? Oh, I see. The camera, this camera, if I'm too high, my hands are, you don't see the context. Okay, all right. Okay, so we have those in. It's better if you don't have any that sort of overlap where you're about to solder. So this is okay. And just a quick check to see that they're all kind of in the middle. It's just nice for the aesthetic. Now, I have this nice JBC station. One of the things that I really like about it, I mean, I really like it, the sort of disclaimers that I got it for half price from JBC, which is very kind of them to give me, but there was no promise for any good words, but it is a really nice station. Right, what I really like about it is how fast it is. So I'm going to use this chisel bit, and if you see here how quickly it heats up. So I'll just put it in like that, and then it detects, and we're already at 345, which is the I'll reduce it to about 330. So we're already there. That's neat because you could also, if you change a tip, yeah, you can just go like this. Oops, it's the wrong way. And then you can just change a tip and it heats up very quickly. We're already there. So that's really neat. So back to the chisel tip. Whoop. Yeah, that's my spool failing. Okay. Okay. Now I'm just going to apply not a lot of solder, just to get that, fill the hole. Right, so we have it, and then I'll just put these, all of them up. Okay, and I have these flush cutters that I cut the lead with a little bit of the solder, but trying not to hit the board, because that would scratch it. When you do that, always hold what you're clipping so it doesn't fly off. If it's small, you just cover it with your finger as you're cutting. Just do it slowly. There's no need to hurry with it. Okay, some of them I see that I didn't get the whole thing. Right, so some of you have seen my video. It's quite an old video now of the solder dome. I might as well cover it now. I should do another video, but what I'm going to do now is apply a little bit more solder to create a nice dome. Now this is nice because it gets rid of all the sharp edges, and it's kind of nice to touch, and it looks nice. But a fair and true criticism of it is it doesn't conform to IPC rules, which cover these sort of things for manufacturing. And it's true, it doesn't. But you know, this is a soldering project, and if something doesn't work, it's not failing in the field or anything like that, or over extreme temperatures. So I think it's okay for these kind of projects, particularly because you're handling it and you just don't want for it to snag on things and just be unpleasant. That was the motivation for coming up with that. So now the trick is to not heat up the whole thing very much, because then what you want is you want to heat up just the surface part and not the whole thing, because then the solder that you're going to add is just going to be sucked into the hole and through the bottom part, and you'll get this like I have here, this kind of bulbish thing, and it looks alright. It looks alright, but you don't want more. Sometimes you'll put more and more solder and then you realize, oh, it's just flowing on the other side. So just heat up a little bit, add a little bit of fresh solder, and that's it. Done. Because remember, the connection is already made. This one is fine. Okay, it's done. So we have these nice kind of balls here, domes, and it's yeah, I like it anyway. Right. So, oh yeah, one of the things that I forgot to mention, this little symbol that I came up with quite a few projects ago is to indicate where the components should go. So when there is any chance of ambiguity, I add that. So you see the component side is here, and then on the bottom side, you see the sort of solder side. So that's why we're soldering on this side, although except the chip, most of these components can go on the other side. Alright, so let's continue on. Let's do the resistors. So this is 470K and this is 150K. So let's do that first. And then I do that thing again. Fold them. Now, one thing that I pay attention to, but sometimes forget, is to place them in the of course, resistors don't have polarity, so you can place them anywhere you want. But it's nice when the colors match. If you have several of them in next to each other. So according to the assembly guide, there's 3 15K resistors go here to these 3 slots. Let's do that. So sometimes I'll have something like this, and if I push on it, I might not get it, it might bend. So I have these old pliers, and what I'll do is I'll just pull from the bottom, and that solves it. Okay, next one, just make sure that it's the right. Am I out of frame when I do that? Yeah, should have bent them a bit more closely to the body. Okay. Right. One more. So again, we look at the reference and we have another 15K here. And another one here. Okay, let's quickly do those. Okay, did I miss any? Somebody was asking me, did I tell that story already? Don't know. Somebody was asking me if I enjoy soldering. A friend came here. He's not, you know, he knows what soldering is, never done it, but he asked me if I enjoy it. And so it's a good question. And then I told him that, you know, it's a good question. But I said, the thing is, whenever I solder something, I'm always very nervous because I don't know if it's going to work. Because I get a prototype, then I'm kind of like, I want to be done with it as soon as possible, so I know that it's working. And when I get a production version, you know, there's always something that could go wrong, and I'm also nervous, and I just want to get it done. So you know, I enjoy the process. I enjoy the working with my hands and building the thing, but I'm also very nervous. Not very, but it's just, you know, there's a certain level of anxiety there when you're trying to build something that you know, has to work. You know, no disaster if it doesn't, but there's always deal with it. But still, but here, you know, here I know it's going to work. And when you guys get the kits, get the projects, you know, it's most likely going to work. So can enjoy it, right? Take your time. Because soldering, I think a lot of it has to do with kind of organization, patience, and thinking before you do anything, really, because you can put the component wrong and then you have to desolder it and maybe damage it, and it's a bit thing. But if you checked before doing it, then you would avoid. But you know, so many times you just do these mistakes anyway, because you're in a rush or not paying attention. Anyway, 470K. So here we have 3 470K resistors, and here one. This time I'm gonna get it as tight as possible. Right. Okay, I'm just aligning the gold of the other resistor with the gold of this resistor again. Not terribly important, but. And here we have 3 resistors. Same way. So I don't like using these helping hands or whatever, but there's some on Slack people saying good things about some of them. PCB Byte or something. It looked very, very nice. I still think that I can do with the dexterity of my fingers, and just use the fingers for to hold things or steady your hand. Like the pinky holding it, that's kind of your pivot, and then another finger to just hold the board in place, and then your thumb and index finger for the solder. I never liked those helping hands with the alligator clips because those always scratch the board. I know you can put some heat shrink on them or something, but I don't know, never worked for me. So yeah, if you're clipping, just put your finger on there, and then it won't fly anywhere. Just a little bit of heat, fresh solder, and you have these nice tomes. Okay. Oops. I have no water in my solder sponge. Okay. Now let's do the capacitors. This one, the bigger one, is the 0.1 microfarad, and this is 220 picofarads. So according to our drawing here, the 220 goes here. The 0.1 comes here. So pull this in. Good. You can do the domes at the end. There's no reason to do them as you go. Probably best do them at the end anyway. But anyway. Okay, so what's next? Next, we're going to do the LEDs. The reason is that if I put the socket and the chip, I'm going to have that part elevated when I'm trying to solder the LEDs. So what I mean is, I'm going to put the LEDs here now, just like this here says, it's the longer leg goes into the square hole. If you put it like that. Now these LEDs have little flags on them. Now, as opposed to the Monarch, these I put larger holes on the PCB, so you don't have to clip them. You just can put them in. And the advantage is that they require a little bit of friction, so they don't fall out, which is nice. But you want it flush with the board and not just hanging. So what I do is this: I place it on against the surface, and I apply some solder. Now you see there's an angle here. Well, you don't see, but there is an angle because this is higher. But that's okay. I'm just going to apply a little bit of solder, and it keeps moving, and it's okay. Just a little bit of solder inside here. So now there's solder, but in this case it came out okay. But what I'll do is I'll heat it up and then press the board against the body of the LED and release, and then I know that it's flush with the board. Now you can see here there are 9 spots or 9 pads for LEDs, but only 7 LEDs, and there's only 7 pips in a die. So, and there's a big X, red X, not to place a component in there, or LED in there. And the reason it's there is for symmetry, but also if you wanted to place a dummy LED in there just to have a nice 3x3 array, you could do that. If you wanted maybe to connect this LED, the pads aren't connected to anything, so you have to connect it to something else. So it gives you the freedom to do that. So I thought it could be useful, but you can just ignore it. Okay, let's do. So well, let's do these two first. Okay, so now they're loose. Put a little bit of solder, heat it up, press, and check. Good. Good. Now you should solder the other side before you continue, because then the other LEDs are going to be in your way. So just solder the cathode. Okay. Cut these. Right. Let's do the middle one. check. Ooh, that came out bad. All right, that's why we check. The other way I sometimes do it is because this won't heat up. I'll just I'll heat up the pad, one pad, right? Press against, let it cool, and now it's for sure flush with the board. Let's do that again. So the orientation's right. Plug that in. Put some solder. Now heat it up. Done. Sometimes I'll do this. You place the solder like that, so you don't have to touch it, and then you just align it. Done. Oop. It's done. Wait, I didn't let it cool. Okay. Oops. I cut the leg without soldering it first, but that's okay. So the domes. Okay, that's done. Now let's do this PNP BJT. Okay, that doesn't really fall. It's a pretty good fit. Here again, I might want it to be exactly straight, so one leg, and then I position it again because it doesn't, the heat doesn't get to the component. Okay, so we have this. Let's do the chip. So here we have the indication of pin number 1, right? This little thing. And it's a square pad, and here there's a little notch here in the socket to say that's pin number 1, although if you solder it the other way it doesn't matter, but if you solder it on this side that's not going to work, right? Because you're going to plug in and pin number 1 is going to go here, and it's just not going to work. Alright, so we place the notch. That indicates that to the left of the notch, the top pin is pin number 1. I just put that in. Again, I'll do the first pin, and then I'll just press it just to make sure it hasn't shifted while I did it, flipped it. I'll also do that for the other extreme. So I do the 2 extremes first, and then I know that it's okay. Normally I would do the domes on these as well, but I'll leave it for now. The chip. The chip normally needs, if it's never been in a socket, it won't go in quite so easily. So I just squeeze pins a little bit. Gently. Sometimes you would do it against the table, but then you might apply too much pressure and it'll bend. Now you can bend those back, but it won't last more than once before you start losing confidence that a pin might be broken. So do it very, very gently. Plugging this in, and then just pressing on it. Make sure that it's all inside. Okay. Yep. Should be a little gap. That's okay. That looks good. Okay. Now, the two kind of interesting things here with the board in terms of assembly. This switch is your regular tactile push button switch, and you can place it flush with the board. So if when you want to press it, you have you can use the other side of the board as counter force, so like that, or you could do it, you could put it flush with the surface of the board. Let's get rid of these flags, they don't matter. So you can put it like this and then press like that. I'll do the flush with the board. So, oh, and you can place it on either side. So you can also place it here if you wanted to click on it from the bottom. Right, so let's do the flush. So I'll just kind of guesstimate where I need to bend it, put it in there, and then sort of bend the legs. Okay, now I have an indication where those are, just bend them properly. Okay. So now I think that was a bit too short. It's okay. Okay, that's fine. Now, so they don't press against, I think I'll use the die to hold it. Now we can fill up the pad here, and now it won't move anywhere. And these two, of course, you want to make it so they're not sharp, because you're gonna, well, in this case you're not gonna press it here, but if you put it flush with the board, kind of want it to be pleasant to touch. Okay, that's done. I keep getting out of frame, right? Okay, now the battery contacts. So, like I said in the previous video, I wanted to use these contacts. They're quite nice and they're not expensive compared to ones that come in on a substrate on their own. And then I thought, well, how could I use them in a sort of surface mount kind of way? Because I wanted the battery to plug in, like you've seen before, like that, you know. So I came up with this. Basically, well, before that, you have a drawing of what needs to go on the pad. So the minus and the plus, and the negative and the positive, and this is the negative, right? And the positive is the one that flares up a little bit. So this will go, oh, we wanted it on the other side, right? So it goes here, and this will go here, like that. Now they don't sit flush with the PCB because they have some metal underneath, so don't worry about that. Let's do this first. So we're going to put it in as much as we can, in terms of it being flush with the board on this edge, right? So we're just pushing it all the way in, and we want this part here to be right against the PCB. There is a drawing of it here, so this is what I'm trying to convey, these two things. This part against the PCB and this part against the PCB, where you leave a little gap here, and I'll show you what happens with that gap. So we're doing it like this. Now, depending on when you do it, actually, sorry, we're doing it like this. Depending on when you do it, there would be nothing to hold against it. So well, there'll be something the table will push on the component. So again, we could use No, how did I do it? Now I'm blanking. Well, one thing to remember, while I'm figuring out how I did it properly, is that this will heat up. And so anything that it touches is going to heat up, whatever touches that thing when you're soldering. So just be aware, if you're putting it on a piece of something that is going to, a piece of plastic, it's going to be hot, right? I think what happened was, because I have my soldering mat, it would be, I didn't care so much if it touched it. But what we're trying to do is solder this again with as close to the PCB as possible. Oh yeah, I remember what I've done. All right, so you use this. Use the die to lift this side of the board up, and then you have this sitting at an angle, and these contacts here are flush with the board. Now you don't need to do you don't need to apply a lot of solder, just enough to make a contact. So again, I'm gonna press on the board to just put it in place, and then just enough to make a contact. There, the contact exists now, and there it is as well. And here there are two reliefs, and I will solder this in place again, just enough to make a contact between the pad on the board and the contact, the battery contact. There you go. So this really isn't going anywhere. It's done, and it's hot. Right. So now we have okay. Okay. So now we have this part soldered, and this part, there's a gap here. Now, it's not necessary really to deal with this gap, not get the gap, but just this contact, but there is a pad for it. So what I've done, if you really want to do something about it, I would just press it slightly down, or don't, as long as you can make a contact even if it's not pressed down, and then just make a little small connection, and that's it. So that one's done. It's yeah, it won't move. Let's do the other one quickly. Flush on this edge, and we'll do the sort of the trick with the die. Contact, 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 sometimes you need gravity to help you out, and yeah, this part here. Okay, we're done. Now, don't connect the battery while the contacts are hot, and they'll be hot for a while. So just let them cool. I'll talk about a little bit about the board here. So there we have it. It's complete. Hopefully it's working. Now you have these two headers on either side, and those break out all the pins of the of this integrated circuit, the CD4060B, which we'll talk in the next video what it can do and what it's doing here. So if you want it, and then the distance is compatible with a breadboard, so you can plug that in. So if you, for example, if you're not happy with the frequency that I've chosen, or you wanted to create a fancier reset circuitry, then you don't have to place these components. You can place them on a breadboard, or create a little adapter, or just you know, float some components and do your own thing. It's perfectly okay. Right. These are, yeah, wait for a little bit. And also, normally after I would do these domes, I would clean this board up, but I won't do it now. Okay. These aren't, the LEDs aren't aligned perfectly. Not sure why. Okay, it's fixable though. Okay, so contacts are cool, and we'll plug in the battery. Now, if you plug in the battery and all LEDs are not all on, you've done something wrong. Disconnect. You don't want to connect the battery the wrong way. So, but this looks okay, right? So plug that in. And now press. Well, it's random, right? 6, 5, 6. Come on. Okay, 2, 4, 3, 1. Okay. 2, 5, 2, 1. All right, you believe me? There's no randomness here, really. There's just the it's just going through all possible states, and at about 7 or 8 kilohertz. So we can't see it, and then when we press the button, that's the random event to stop the oscillator here, the built-in oscillator, and that gives us the number. But we'll talk more about that in the next video. I think that is it. When you remove the battery, just remove it very gently. Not because of the contacts, but just you know, sometimes the connection is quite solid, so it's good to do it gently. Also, when you finish with it, of course, just disconnect. These are remarkable LEDs. I have to say, these are Cree LEDs. They're very bright, and as you see them, each one of those LEDs is consuming less than half a milliamp, so 500 microamps, less than that. So when I first built this, I think I had 3.3K ohms to control the current. Doesn't matter. I mean, it's just for in comparison. It doesn't. I can't remember what a few milliamps, and it was so bright. I decided to get to lower the current. It's great because of the battery life. And I went up and up and up, and I ended up with 15K was the value, 15K in series with 2 LEDs, except this one. Well, here's the schematic, but anyway, this is for next time. Over 9 volts, so it's getting less than half a milliamp, which is quite. It's very bright for that kind of current. Total, I think it's consuming 2 milliamps because the chip consumes a bit on top of the LEDs. Yeah. So there, enjoy the project when it arrives to you. If you're in Canada, it'll probably take a while. You know who I'm talking about. Well, let's go to me again. Thank you for bearing with me. How long have I been rambling? An hour. Yeah, somebody's gonna complain. I know. It wasn't short and sweet. Okay. That's just some banter from Slack. Right, thanks for bearing with me. Enjoy this project. Next time, I will go into detail about the circuitry and how it does what it does, and talk a little bit about what a ripple counter is, and binary counting, and put some stuff on the scope, and I aim to do it at a very basic level, just hopefully it'll be educational to some of you. But yeah, that's it. Thank you. Bye bye.